Okay. First of all, I don't know how many of you are in astronomy or have taken astronomy or are interested in astronomy. Astronomy. Oh, Morgan, did you raise your hand? Okay. Planets orbit in elliptical patterns. Okay, do you talk about that in astronomy? Yeah. Okay, so here I have an example. Like here's the sun at one of the focus points and the planet orbiting around it. Okay, obviously every planet has a different ellipse that it follows, but planets orbit in elliptical patterns. So something useful. Okay, so let's remind ourselves about all of the pieces of an equation for an ellipse. Okay, this center, in general, we label that point with what letters? That is HK. All right. Josie, how far away are these coordinates right here from the center? Those are A away. Okay. Michaela, how far away are these points from the center? Those are B away. All right. Eric, how far are the foci from the center? They're C away. Okay. Grant, how do we get C if we know A and B?
You take.
Remember that equation?
It was C squared equals A squared minus B squared.
Excellent. Okay. Michael, how do we calculate eccentricity?
B over A.
You seem unsure.
C over A.
C over A. Did you look back at your notes? Get some confirmation. Okay. Eccentricity is C over A. And then, Sean, did you have your answer?
Yeah, I'm really confused by eccentricity. Like, what is that really used for?
It's basically just a measurement of how circular versus oval are ellipses. So the higher the number, so eccentricity is always between 0 and 1. The closer it is to 1, the more oblong it's going to be. The closer it is to 0, the more circular your ellipse will be. Okay? Maddie, if it is a vertical ellipse, how do we tell that by the equation?
Under y, it's a bigger number.
Okay, so underneath the y squared, it's going to be the bigger number. And those numbers underneath are they A and B? Like this, A and B? A squared and B squared. And then flip-flop if we want vertical, right? Okay, so today we're going to go backwards, okay? We're going to get information about an ellipse, and then you're going to have to write the equation, all right? So we're going to do this a little bit differently. I'm going to put up 2 problems at a time, and I'm going to give you about 5 or 10 minutes to see how far you can get on both problems as a group. Okay, you're going to work together in your group to try to figure out what the equation is. Does that make sense? Okay, so okay, here are the 2 equations. Can you see those well enough? Can you read those okay? Okay, so I'm going to give you 5 to 10 minutes to see how much you can write of our equation. So like the x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay? Some things you can look for. The center, A, B. Those are the kinds of things you're going to need to write your equation. All right? How many of you drew a picture for this first problem? Oh, good. Okay. So we have vertex and, whoops, foci. Okay. Pod 1, what's the first thing you identified from this picture? Okay, and what is A? All right. Pod 2, what's something else you identified from the picture? The center was at 0, 0. Okay, so here's our center because it's in the center of everything. And then pod 1 said, okay, well, our vertices have to be A away, so A is 6. Okay, pod 3, what's something else we can pick out from the picture? C is 2 because that's how far away the foci are from the center. One more thing we know about the equation of the ellipse based on the pictures, pod 4.
It's horizontal.
It's horizontal. So we know we have x minus h squared, y minus k squared equals 1. A squared has to go with the x, b squared with the y. Okay? So we can plug in our center, 0, 0. And we know a squared is 6 squared. Okay? Pod 5, how can we determine b?
C squared equals A squared minus B squared.
Okay? So we have 4 equals 36 minus b squared, which means b squared is 32. Okay? What's nice is we want b squared. You can say that b is radical 32, and that's great, but then you're going to have to square it again. So I'm just going to stop here and say that my b squared is 32. Okay? Some of us were getting hung up on trying to simplify radical 32. In this instance, it doesn't matter because we have to square it when we put it back into our equation. Okay. Any questions on the first one? You guys are doing really well with this first one from what I observed. Okay. Second one, 0, 0, and 4, 0 are our foci. And our major axis has a length of 8. Okay? So, pod 6, what's one thing we can take away from this picture? The center is 2, 0. And why? Excellent. Pod 1, what's something else we can observe from this information? And that is because the foci are 2 away from the center. Great. Pod 2, what's something else? Okay, can you explain that one for me?
Vertices, like the major vertices lie on the same axis as the foci, and they're it had a length of 8, so split that in half, and that's the distance.
Okay, so the major axis has length of 8, split it in half, and that's the distance from the center. Good. So that tells you what about the information that we need to write the equation. If we place our vertices there, then we know what value.
A.
Mm-hmm. And so A would be 4, right? Okay. Pod 3, one more thing we know about our ellipse. What kind of an ellipse is it?
Horizontal.
Horizontal. Great. So we know we have x minus h squared, y minus k squared, and since it's horizontal, a squared goes with the x. All right, so what we can do is we know our center is at 2, 0. We know a squared is 4. Okay. Pod 4, how do we get b squared?
C squared minus C squared equals A squared minus B squared.
Excellent. So 4 equals 16 minus b squared. So b squared is 12, right? Excellent. Good work. That was a great team effort. Okay. Those are pretty basic examples, and it's really not going to get that much more complicated, but we have a couple different types of information that you're going to see. So here are your next 2 problems that I'd like you to work on together. You have about 10 minutes. Okay? Okay, did this first one even need to tell you where the center was?
No.
It didn't, right? Because they gave you the foci. But they did say that the center is at 3, 2. Okay? Pod 1, what kind of ellipse do we have? We have vertical. And they've told us that the center is at 3, 2. Okay? Pod 2, what else do we know?
C is 2.
C equals 2 because,
Not far away from
okay, the center to foci is 2. All right, pod 3. How can we use eccentricity to help us? Okay, we know that eccentricity is C over A. So our eccentricity must equal C over A. So Nate, what is A? Great. So we can go and change this to 36, right? And I guess while I'm at it, I'll change this. Our center's at 3, 2. Okay? Pod 4, how do we find B?
C squared equals A squared minus B squared.
Man, that has sure come in handy, hasn't it? So B squared is 32. good? All right. Good teamwork. One more. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Pod 5, tell us something that we know. C is 2. Pod 6, tell us something that we know. The center is at 0, 0. And those foci are 2 away from it, so that is why Maddie said C is 2. Back to pod 1, tell us something else. B is 8. Why pod 2?
Because it says in minor access is the 0 plus minus 8.
Okay, so these are what I've been calling our minor vertices, right? Okay, I'm gonna go back to pod 6. What kind of an ellipse do we have? Okay, and pod 4, why is it horizontal?
Because the foci.
Oh, because the foci are horizontal from our center. Excellent. Okay, so we know we have this. I went ahead, I'm not going to write minus h and minus k because our center's at 0, 0. I'm getting a little leaky here. All right, so we know that b is 8, which makes this denominator 64. And everybody all together, how do we find a squared?
B squared equals A squared minus
You are never going to forget that, are you?
Yes.
You are going to forget it?
Eventually, yes.
Okay. So b squared is 60.
Isn't it A squared?
Don't listen to me. We are looking for a squared. Thank you. So a squared is 68. See, and you know what? That is why today you guys taught each other, right? Wasn't that great? I didn't tell you really a whole lot. Anything that I said is what you guys did. I think that's pretty awesome. Here's your homework.